Let me get all my chats working. 1 second. Activate. Auto find. Activate. Yes. Cool. Visible. Visible. Should have all the chats working. I hope I do. Let me know if it's not working. Let me start office hours here. Oh, what's up, Frizzion? What's up, Justin? Yo, yo, yo.
Check your DMs, pal.
Check my DMs, he says, dog. Go check my DMs. So I need, like, this thing to be in the right place now. Ooh. What's up? One sec. Almost there. I just gotta. One second. I gotta switch this to this. I have so many things. So many things in the world these days. That's what I get for like trying to stream on 3 platforms at once. Okay, one sec. I'm going to my DMs because you said you sent me a DM. Yes. Here you go. That Twitch clip of us playing. I slipped that night.
Don't read it, man. Don't read it.
Oh, that slip. Oh, yeah. Okay, yeah, whatever. It'll go down momentarily, or I'll go take it down manually. It's fine.
All right.
I appreciate you looking out for that. Yeah, I used that footage for our I did it for our new web page for the summer and stuff. So here, if you go to like 1 second, let me pull this up for people so people can see.
Yeah, wait, you get a preview? You get a preview?
Yeah, a little preview. 1 sec. I do totally forget we were live during that. Yeah, but if you go to the website, so I changed the video here, right? So the main video now shows some more recent stuff that we were doing, right? So that was me playing Fortnite. I think I have whatever. It's just like, yay, look, we do math and we also play video games. This was me playing I forget whatever the game is. It's a great one on Roblox. And then there you go. There's us playing Doors, and you throw the box at me, dude.
Oh, you're not streaming on Discord.
Yeah, I'm not streaming on Discord. Yeah, because of bandwidth. Here, 1 sec. I can probably change that. But yeah, that, and I created a new. I probably shouldn't open my Dropbox like live here. Give me a second.
Yeah. There's personal files in there.
There's personal files in there for sure. Also, why is all of this stuff being... 1 sec. What? If we go to office hours... What? Oh, it's showing that one. Try to, like, figure out... OBS is having a difficult time... OBS is having a difficult time determining, like, which screen to look at. 1 sec. Let me go find the Dropbox.
I'm hearing in my way.
1 sec. Move closer to your mic. I can't really, like, hear you, dog. It's hard.
Sorry, it's because I have my phone set away, but I said that Twitch is running away from me pretty much. It doesn't want me to download its app.
Oh, really? Uh-oh. Where did I have it? Did I have it in summer camp? I put it somewhere here. Actual education. I want to say I put it in ads.
Super Mario Bros. Marathon.
Here we go. Here, 1 sec. Let me beam it to you real quick. I'm gonna put this on this. I'm gonna share my screen, entire screen. This is probably gonna crash my bandwidth, but there you go. And then let me find the summer camp vid I made.
I'm loading up your one screen. Okay, I'm on a 20-second ad.
Oh. Yeah, here we go. 1 sec. So this is the ad I made for the summer. So this summer we're running like a virtual summer camp, so students don't have to experience summer learning loss. You can learn cool math stuff with us over the summer. We're also going to play a lot of video games, and there's a tournament, and you win prizes, and it's super fun. If you haven't signed up yet, it's on our Discord. Just sign up, or you will probably get hit with one of these ads because I just told Google to spend like $100 a day on it. It's all free, by the way. Hey, Gold. What's up, Apex Chasm? Good to see you, dude. Anyways, this is what the ad looks like. Let's see. Let's watch it. Here, let me turn the jazz music off. Or whatever. Win real prizes and learn cool math hacks. Anyways, that's a little ad. That's what we got. This jazz music is way too loud.
You throwing the box at you though.
Yeah, isn't that the funniest, dude? You throwing the box at me? It's like, Default user says, yo, man, sorry I've been gone for a while. I feel really bad. Oh, don't feel bad, man. It's okay, dude. Like, people come and go. Totally cool. I'm glad you're here, dude. Glad you showed up. How's life? Are you doing all right? I taught it was my third lecture today in physics. We went over a lot of cool stuff. We went over Archimedes' principle with like buoyancy. We did the Bernoulli equation, which I guess is Torricelli's law. I felt like popping in, but yeah, I'm doing fine. Oh, great, dude. Love to hear that. Love to hear that you're doing better. More than ever. Hell yeah. Okay. And then, yeah, I did some Bernoulli stuff. Yeah, if you were watching today, it was pretty cool. So one of the better lectures I think I had today because I just had more time. I wasn't really dealing with as much like administrative stuff. Stuff like always like annoys me. But anyways, yeah, let me delete all these pages. Because we're going to do some new stuff today. Let me get rid of that. Sensations up in the house. Good to see you. Dude, I hate these ads they're now showing, bro. This is so annoying, man. Do you see this shit, dude, on Discord? Like, look at this stuff. It like pops up and... Dude, this is gross. Like, I have to be like, no. No, hide this. I don't want to see this. So annoying. I don't want to see these quests.
Test, there we go.
Yeah, I can hear you, Sensation. You're good.
No, like I said, I don't get ads of any kind.
Really? How do you get no ads on Discord?
No, for anything. Ever.
Yeah. Oh.
I built a DNS server like 10 years ago.
Ah. So...
no, you're not giving me ads. If I want to buy something, I'll fucking tell you, cunt.
Yeah, I sometimes like when they advertise things that, like, I didn't really know I wanted, but the advertising, the algorithm knew I wanted. But you're right. In this case, it's like random Discord quests for, like, games that, like, I don't play. Like, no. If you want to show me, like, something for a game I play, sure, that's cool. You can disable the ads? Oh, can you? Oh, please, default. Tell me. He says, one funny thing is I've used math in Roblox of all places. Wow. Basically, in the game SCP-RP, you can host a custom server and build stuff, and I've used some basic math to size stuff correctly. Wow. Isn't that sick? Yeah. Okay, where do I turn off the ads? Oh, in-game rewards. There it is. Yes. Wait. It says I might still see quest promotions. But I don't want to see it anyways.
Can't spell ads without AIDS.
Well, you can't spell AIDS without ads. What? No, you can definitely spell ads without AIDS.
I don't know, whichever way around it was.
Whichever way around it works. Yeah, I don't know. Whatever. They're being wacko with things. I get it. Like, Discord's been free for so long, and now it's trying to make money because I think they're going public. I think they IPO'd or something, or whatever. They got a new CEO, and they're like, "Yeah, cool, awesome. We built this great thing that everyone uses." I do love Discord, but now they're running into the age-old problem of we've been burning through VC cash, and now our investors want to see a return on their investment, so they have to find a way to monetize it. And I guess they tried to do this with Discord Nitro and like boosts, which, I mean, I pay for a decent amount of boosts. Sensation, you boost the server. Like, we pay money into the Discord ecosystem for sure, but I guess not enough people are doing it.
Or they just got greedy.
Or they just got greedy. That's true.
But I mean, it's all a matter of choice anyway. A piece of software can remain good and improve itself without having to ever pay for it. VLC is probably one of the big ones on that in that context. God, I can't even talk now.
No, you're good. Yeah, VLC. I love VLC. Yeah, the Videoland, the age-old, the traffic cone video player. Yeah. I think they stay alive. They stay alive with donations, I'm pretty sure, right? Or there's like a foundation that gives them cash.
Probably.
I understand that Discord has real expenses because, yeah, to host the amount of, media and users and whatever that's going on, you need big servers. Servers cost money. I think it's crazy that, for instance, even in our Discord, like, it saves every single message. I got stuff back from, like, 2021 that I can still look up, which is crazy. Because then multiply that by, like, how many thousands, if not millions of servers there are. I get that there are expenses. I think it's tricky. I don't know how they're going to monetize Discord and not piss everybody off to, like, leave Discord.
See, this is one of those things that comes with age. Just because I'm a bit older than you, I remember the internet being free. In both the monetary and the political sense.
It was supposed to be free, right? It was also supposed to be free access, right? Even the idea of like cable providers, right? Internet service providers. I don't think we're really a thing, right?
I've always paid for the internet.
I thought at one point, like, this was big, I think, 10 years ago. Do you remember net neutrality? When everyone was arguing about net neutrality?
Yeah.
Basically, they don't want the internet to become like a tiered system where, for instance, like Netflix pays more money and they get more priority to their traffic. I think that was like a big thing that people are arguing about. What's up, Sebas? Linux is an example of bigger and better. Yeah, you can't pay for Linux though, for sure, right? Linux costs money in some cases. If you get like the
Enterprise, I think is the only one that I can think of.
Yeah, I wish that net neutrality. I wish that net neutrality was still the worst thing. Yeah. I remember, when net neutrality was the worst thing on our minds, not fucking World War III. Anyways, so it goes.
All of you implying like wars haven't been going on since I was born, you know?
Yeah, and you've been involved in some. Oh, actually, I just got a message. I just got a message from Discord. Look, they just sent me a message here. Look at this. Whenever like Discord sends me a DM, I'm like, excuse me. Updates to server boosting. What's new? We're giving you more ways to customize your server with additional perks. Use available boosts to unlock these perks directly. No server level required. Ah. Okay, so now they're really leaning into the boosts. Server tags for 3 boosts. Custom 4 character tag. Oh, that's what I see on some. I see on some Discord users. They have like a tag next to them. Enhanced roll styles, gradient and holographic roll effects for 3 boosts. I mean, that's cool. But I mean, a boost each, I think is what, like $2.50, $3. So that's like $9 a month for people to just have like cool holographic stuff on your server.
Yeah, it's not exactly worth the money.
No, I do like the tag thing. I have seen, so the tag thing is like they have something next to their username that says like, I don't know, whatever, like it's like a 4-letter thing. I'm trying to think what ours would be. I guess it would be like ACTL actual. But it used to be only for guilds. They were only rolling it out to like certain like guild servers, and I know we weren't really like reached out to. So okay, I get it. That's now a monetizing thing for them. Oh. Okay. Whatever. I guess they're trying to make money. I mean, that's kind of cool, I guess. Oh, I do see it like on my user here, like Justin, for instance. You have like an SG2 next to your name. You have this thing. Splitgate. Yeah, but it says like for instance like it has a little tag next to him, so I guess that means Splitgate. That's cool. Nice. 1K you accepted. Cool. Dope. Awesome. I'll send your gift soon. Yeah, actually, maybe I can do it now. I don't know. Do we have any questions yet? I don't think I've seen anything in the server. And welcome if you're here from my UCLA course. This is office hours. If you have any questions about anything we've been going over or any of the homework, please like let me know in the chat, and we can go over it. You could literally just say like, "Hey, homework 1, question 6, I don't get it." and we'll go over it. What's up, 1K? I just got your DM. Thanks. Sebas says, I don't want to use Discord because most people I know have been groomed. Oh, interesting. Is that a thing? Like grooming people on Discord?
I've heard about it in the background, but never come across anyone that's actually seen this.
Yeah, no one's like tried to groom me. I mean, I don't know. Am I like chopped liver or something, dude? I guess I'm too old to be groomed. That's really what happens. I see the whole like.
Me,
go on.
Isn't Sebastian University?
Sebastian University? What's that?
I thought Sebas was in the university.
Oh.
Thought that was one of your students.
Oh, no. I think Sebas is... Sebas, are you from UCLA? He is a minor. Okay, so I don't think Sebas is from my UCLA course. Here, one sec. I'm logging into my Steam for you. Oh, I need Steam. That's one of the last people who's like still doing good things for the world, right? The CEO of Steam. He's like a really cool dude, right? I think Steam is one of the, or sorry, I'm thinking Valve, which is Steam, right? Yeah, they're the same thing, right?
Yeah.
I think they're one of the most profitable software companies per like they're incredibly efficient at like using their workforce.
And they still won't release Half-Life 3.
I know. I fucking love Half-Life 2. One sec.
They did make Half-Life, a couple of Half-Life games, but they were terrible.
Did you? Yeah, what was it, Alex and stuff, right? Half-Life Alex, and then which I bought. It's for VR. I still haven't like used it yet. Sebastian says he found us naturally, which is cool. That is dope. Yeah, look at that. Like, yeah, natural organic reach. Yeah, that's pretty cool. Here, let me gift this to... Wait, what's your username, 1K, by the way? You just added me, sorry, but like, what is your username? You want to tell me real quick? Like, what's your username on Steam? I want to say it's... I don't know, actually. Oh, it can be up to 4. Yours is 3, for instance. Default user, UNN. Oh, that's cool. Yeah. I mean, I'll look into it. Again, if we had, like, extra boosts, yeah, I would for sure just, like, spend them on it. But, the main thing I like is having level 3 because it gives us the unique URL that works. So, for instance, that discord.gg actually to you, that one requires us to get to level 3. It's probably the most useful thing because I think when people see that, they trust like what we do more. They're like, oh, this is probably legit. Where's like my friends? One sec. Can I not see who my friends are?
It just occurs to me.
What's up?
You own a URL, don't you?
I do. I own a lot of URLs actually. I own a ton of them.
I mean, you could set up your own there too.
And yeah, I do. I do have like, for instance, like discord.actual.education. That website will go straight to our Discord. I just think people trust the discord.gg more. They're like, oh, it's an official Discord website. I'm like, yeah. Pending invites, recently played with. They don't really show like who just added me. The stream is lagging a bit for you? Okay. We needed something to do. We got to evaluate 2 + 2. I have tons of stuff. No, we can go through other questions. I'm just taking up some time here to see. Because technically this is my office hours for my UCLA course. So I wait to give a little bit of preference to see if anyone from UCLA has any questions about the course so far. And if they do, like, you know, I'll help them. Okay. Yeah. Sure. Yeah. Discord's good too. Let me make sure all our streams are running. I'm pretty sure this one's running too, which is good. Yeah.
No lag from my end.
Yeah, it looks good on mine. Yeah. Okay. Cool.
That's what you get for using a phone.
I'm gonna leave Twitch chat open so I can chat. Okay, cool. You can also visit any of the YouTube links too if you want. Those should work as well. And I think should have pretty low latency. I turned on this like ultra low latency mode that they have, which I think makes it so it's quicker. Like it doesn't prioritize the quality of the encoding as much. Which again, do I need like the absolute best encoding quality? Can't you pop out the chat, or is that YouTube only? I think it's YouTube only. I don't think you can do it on Twitch. Unfortunately. Oh, I need my Sammy up. Sorry. Let me get Sammy going. There we go. Now Sammy's running. I have it set up so if you type like a chat here. There we go. Thank you. It'll pop up the chat at the bottom there. Needing to hydrate. Okay. Dun, dun, dun. Yes, yes. Cool. Test. Fire. Okay. Let's start off the stream. I'll go through and answer some questions and help you guys out. There we go. Welcome everyone. Office hours. My name is Dr. Gold, this Actual Education. Streaming helps you with math homework, science homework, all sorts of fun things. Might be a short stream today if we don't have that much to go through. It's all good. I did want to go to the gym today, and I just had no time this afternoon between like getting ready for my next class and everything. There's a lot going on. Here. Let's see what we got. I think if someone's submitted something here. That was that. Ooh, this is a good question. Sure, Google. Yeah, Google account. You want to send me a question? We'll do it. Jaden says, when is the summer camp in Discord? Good question. That summer camp starts, I believe, July 7th, but you can register for it now if you want to see where it is. So if you go within our Discord, and it's one of the first things here, summer camp, and you go to like read first here. This kind of describes what happens, the prizes, and then in order to register, all you got to do is go here and click register. That'll pull up this form for you to fill out. And then once you fill out the form, and I'll process these today because it's been the first week, you can then get credit every day by just like going to the announcements channel here and doing ! Daily. And then also you can look and see what the scores are, which are everyone's at 0 right now because we haven't started summer camp yet, but we'll do like kind of like a pre-registration like test run for people to get points. Maybe I'll give out like, I don't know, some V-Bucks or Robux. But yeah, if you go through, register on that Google form, I'll get the registrations processed this week so that you can start like earning coins during the registration period. Nice. Oh, 1K, you did give me your thing. Okay, nice. Let me get that. And then if we have some other web help stuff coming in, it'll work. Okay, here we go. Ivan. Cool. Here, congrats. On tier 3.
Oh, I hate Spanish.
You hate Spanish? What's wrong with Spanish? I like Spanish.
It says, and I quote, Z is pronounced like TH in month or thick.
Is it?
Voth, loth, path, veth, zapato. It says it right here.
Let me see.
How's your Spanish?
My Spanish is actually pretty decent. I'd say I'm at like a, like out of 10, I'd say I'm like a 4 or 5. Conversational at least.
What's VOZ?
Vaz? Like voice? Vose?
Yeah. L-U-Z.
Yeah.
What's zapato?
Uh,
Or zapato?
zapato. That's Spanish when they. So people in Spain pronounce it as a th. In Mexico and stuff, it's a z, and that means shoe. Zapato is shoe. Jeff says Castellan pronounce it as th. Yeah, it's a weird one. All right, 1K. I gave you your gift. You should have gotten. I bought you NFS Heat, so congrats. 1K's been in our server for I think almost a year at this point, and we have a system where if like you ask questions and get help or do different activities such as we have what is it the good grades challenge where like during the school year if you submit that you have like good grades in your classes like once a month, you get points for that. Where was that? Where's our good grades channel? Here it is. Yeah. So students show me that like, hey, look, I did well on my classes. I'm like, great. That gets you points. If you show me you did a certain number of steps in a week. So here's people, you know, showing how many steps they did different days of the week. That also gets you points. And we also have a music class. So some people will submit videos of them practicing an instrument. That gets you points. Bunch of stuff. And then once you have enough points, you go to the prize room here and you redeem a prize and I buy you a prize. And it's cool. We've given out a lot. I think I've given out almost $10,000 in prizes at this point. Some of that's been funded by other people, but a lot of it's been funded by me personally.
You've been at this for 5 years.
I have been at this for almost 5. 4 and some change. 4.5. 4.5. Yeah, I think 4.5 years we've been doing this. Ooh, nice. We got a question. Ooh. Here we go. While Sensation learned some Spanish for us. ¿Dónde está la tarea que necesitamos laborarlo? Right? Where is the homework that we need to work on? Okay. So here it says.
All I can remember is lávate las manos.
Lávate las manos.
Wash
thanks.
your hands.
Wash your hands. The ends of a light, inextensible string are fixed to 2 points, A and B. Very cool. In the same vertical line with A above B, the string passes through a small ring of mass M. Okay, so this has a mass M, and the ring is fastened to a string at point P. When the string is taut, the angle APB is a right angle. Oh, that's very cool. That's nice. We like that. And BAP is theta, and then the distance of P from AB is equal to R. Okay, cool.
Don't start calling it BAP. You know what a BAP is over here?
Yeah, what is it? What is a BAP? Big ass person? What's BAP?
Bread roll.
Oh, a BAP. Like a kebab?
No. Soft bread roll. Like, I don't know how to explain it.
Oh, okay.
A bread roll, but soft. So you say, "Oh, I'm gonna go get a sausage BAP."
Like okay, let's get a okay. Like ciabatta. Yeah, okay. It's kind of like ciabatta, no?
Ciabatta's different.
A Belfast BAP. A delicious Irish bread roll. Love that.
And they're different as well.
That's funny. Oh,
inconsistent.
I don't have the kudu stuff open. Sorry, where was my thing? There we go. Okay. The ring moves in a horizontal circle with a constant velocity omega. By resolving horizontally and vertically, show that the tension in the part of the string BP, okay, show that this tension is equal to a certain amount. This is very cool, actually. I really like this question. Thank you, Google account, for sending this. Sorry, here. Let me copy this somewhere else, and then we're going to start drawing some pictures and some force diagrams. So, the first thing I'm going to do is I'm going to draw like a force diagram for what's happening here, right? So you have a block, okay? And that is going to have some forces on it. So first force you have is the force of gravity pulling down. So this is going to be mg pulling down. You then have tension in two different ropes, right? So we have tension from here. Let's call this like T2, for instance. And then we have tension from this rope here, which we're going to call T1. And then, let's see. I need to like kind of draw some axes lines. Because if this angle here is theta, that means that this angle here is theta. And then we know this is 90 degrees, right? We said earlier in the problem that the angle that these two ropes make is 90 degrees. So yeah, exactly. The normal reaction force on the ring axe, yeah. It has to do with centripetal acceleration. That's why this question is actually kind of tricky, I think. So if that's theta, this is 90. So this is 90 minus theta, right? I think that's what that tells me, right? Which I believe then that this is theta as well. Yeah, this is theta. It's kind of cool. Yeah, so then this is also theta. Reason for this, right? If this is theta, this is 90, the whole thing is 180, right? So this, you have x is equal to, so you have x plus theta plus 90 is equal to 180. So then x plus theta is equal to 90. And then I know that this is 90 degrees, right? So then, sorry, what am I saying here? Sorry. Right, okay. So then theta is equal to 90 minus x. Okay, cool. And this right here, right? This right here is 90 degrees. This is 90 minus x. Whatever this angle is. Yeah, okay, cool. Yeah, okay, cool. That's where it comes from. Don't worry about the x. We actually don't care about what this angle is. Okay. So I can now take this, and I'm going to, like, put this somewhere else now. Put this right here. And now here's our force diagram for, like, what we got, right? And I'm going to do the sum of the forces in each direction, okay? So for sum of forces in the x direction, right, we're going to have the component of T1, which points in the x direction, which is this amount. So that's going to be T1x. And that is the sine of theta right here. Correct. We do need, yes, T1 and T2 need to be the left of the orbit. Yeah. So the key thing here is that because this thing is spinning around in this direction, it needs to have centripetal acceleration that points towards the center. And in order for there to be an acceleration by F equals ma, you need a force. And so that means that the tension in these ropes need to pull me in somehow. So that's why I have the ropes, you know, pulling this way and this way. This is mechanics, Nico Swag. It is, yeah. It's just a question someone asked. If you have another question, yeah, submit it. I'll go over it. This is a mechanics question. Okay, so you have negative T1 sine of theta. That's this. And then I have minus T2. That's going to be cosine of theta. Right? Because looking at T2, right now T2x points in the cosine version of this. Right, so this is like T2y. So I put that over there. Okay. And that's it for left-right forces. Okay, now for up-down. We're going to have positive T1 cosine theta minus T2 sine theta, and then minus mg. And this all has to be equal to 0, right? Because the sum of the forces in the up-down direction has to be 0 if it's staying in one place. And then it turns out, if this thing, again, is rotating in a circle with an angular velocity of omega, that means it has an angular acceleration or a centripetal acceleration. It's not an angular acceleration. It has a centripetal acceleration. So this is going to be equal to MAC. And AC is equal to, it's usually V squared over R, but V is R omega, so it's R squared omega squared over R. So it's equal to R omega squared. I think. I felt like I had a good grasp of the concepts in 1A. I totally bombed the test, though. Uh-oh. Who did you have for that class, by the way, Nico? Who's your teacher? I'm curious. Curious who's making exams that... I had a policy in my in my 5A class where when I gave out the midterms, if there were certain questions that all the students were getting wrong and I needed the class average to be a little bit higher, I would just drop those questions, because I'm like, okay, if everybody got the question wrong, it means A, like, I didn't teach it, or it's a bad question. And in either case, like, you shouldn't be penalized for that. That's that's the teacher's fault. People always get like kind of, if everybody's failing a class, it doesn't mean the kids are stupid. It means the teacher's not teaching or is not assessing correctly. Yeah. So yeah, this is how this works. R omega squared. Nice. Okay, what the hell are we solving for, by the way? Sorry. Show the tension in string BP. Okay, so they want the string and tension BP, so that's T2. They want us to solve for T2. But this is how you set it up. That's how you set up the question, all right? Now we ask ourselves, solve for T2. And I'm going to take my equations here, because these are useful. Another key thing I almost got wrong here. Uh-oh. This needs to be negative MAC, because the centripetal acceleration points to the left. This is AC. Okay, so this is also negative. Oh, you don't think the tests were bad? I just blanked when I saw the questions on the paper. That happens. Testing anxiety is real. I would say the number one way to get over that is to basically put yourself in the same environment and just... If an environment like causes you panic, I think my therapist friends know about this. It's something like, it's called exposure therapy, I think it is. Like if something causes you panic and anxiety and trauma, you need to just like constantly expose yourself to that thing, and then it no longer bothers you. So if tests like really make you anxious and upset and you blank and you don't do well, just keep exposing yourself to like tests. Or like, create like mock tests environments. Too often I'll see kids that are like studying or doing homework, like with the TV on, or again with like, ChatGPT's running, or like they're just, relaxed in their bed or something. And when you do that, your body doesn't get used to a testing environment. So when it's in a testing environment, it's like, oh shit, this is totally new. I actually don't know how to perform in this. And then you end up like screwing up on tests. So a little bit of advice. My dad used to always say, like, a time and a place. Like, anytime we were going to go, like, study, he'd be like, get off the bed, like, get off the couch, like, go sit at a desk. Because there's a time and a place for studying, and that is at a desk. Back in my day, we didn't really have phones to distract us either, so that was okay. But I would say that's, like, probably one of the number one things to do now when practicing to take tests is, like, get your phone out. Like, do not look at your phone. Don't even have it next to you, because that's the number one source of distractions. Yeah, for sure, man. I mean, you're not alone. I've had a lot of students talk about blanking, and, sometimes it helps them. All right, anyways, we're looking for T2 here. So I'm going to, first of all, I have minus signs everywhere here, so I can just get rid of those, right? So we're just going to get rid of these. Sorry, this was gone, this is gone, this is gone. Okay, cool. And I'm going to isolate each side for T2, okay? So from here, I'm going to get that T2 sine theta is equal to T1 cosine theta minus mg. Right, so all I did is I just moved that over. And then from this one, I'm going to get that T2 cosine theta is equal to R omega squared minus T1 sine theta. I just looked at forward and inverse kinematics today, mildly scared and overwhelmed. Oh, well. Don't be scared. If you have a question about it, you know where to do it. Just like submit a screenshot down to us, and I'll go through it. Like we're doing. This is a kinematics question right here, or not kinematics. Sorry, it's called dynamics technically, but yeah, it's mechanics. Okay, so once you have this and this, I'm going to show you a really cool math trick. So what I'm going to do is I'm going to take this thing, I'm going to pull it down so that it's here, okay? And then I'm going to divide this by this. So watch what I do here. I'm going to take this and put them over each other, okay? Oh, actually, fuck, that gets rid of T2. I don't want that. Oopsies. No, never mind. That's getting rid of T2. I think okay, I know what I want to do. Sorry. I have to rearrange these for T1. Let's rearrange for T1. My bad. All right. Here. Let's rearrange. So I'm going to have T1 sine theta is equal to R omega squared minus T2 cosine theta. This is what I wanted to do. And then here, I'm going to say that T1 cosine theta is equal to mg plus T2 sine theta. Okay, now here's the cool thing. Now if I divide this by this, okay, so the T1s will go away, and then I'll have things with cosine theta and sine theta, which, what are we trying to prove? We're trying to prove, yeah, okay, cool. Although I'm going to get tangent. Interesting. Let's see what happens. I'm curious. Okay, so divide this out. So this goes away. And I'm left with sine theta over cosine theta. Sine over cosine is tangent. So I'm going to say tangent of theta is equal to R omega squared minus T2 cosine theta all over mg plus T2 sine theta. Now I can take this and move it over here. So we have mg tan theta plus T2 sine theta tang theta is equal to R omega squared minus T2 cosine theta. Let's move this over here. Let's move this over here. I want to get the T2s next to each other. So T2 sine theta tang theta plus T2 cosine theta is equal to R omega squared minus mg tan theta. Now I can pull out the T2s. I'm going to get that T2, and then this is going to be sine theta tan theta plus cosine theta equals R omega squared minus mg tangent theta. This is physics. It is. It is. And then I'm going to move this under. So then we're left with T2 is equal to this divided by this. Cool. Let's see if that looks like what we need it to be. Yeah, you can send memes. Yeah, you can definitely send memes default user if you want. That's really cool.
If you ever feel useless, remember that the Scottish Gaelic Duolingo course contains the phrase, I do not like whiskey.
That's a good one. Alright, this is what we wanted to show. Let me see if we can get to it. Okay, this is what they wanted us to show. Okay, I have R omega squared. Minus G sine theta. Okay, I think I see what they want us to do here. I'm gonna rewrite this tangent of theta as sine over cosine. It's kind of dumb, but I can get it to look like it. Watch. So sine theta all over cosine theta. And then I'm going to rewrite this as... Watch this. Yeah, exactly. I'm going to write this as like cosine theta all over cosine theta. So I'm multiplying by 1. I'm multiplying my cosine theta over cosine theta. So now what this will give me. Oh, and I did fuck up here. Sorry, earlier. Sorry, this is mr squared omega. Sorry. Oopsies. Sorry, it's MAC. AC is r squared omega, so it's mr omega squared. Let me fix that.
Just quickly,
What's up?
Factum, or whatever, however you pronounce that, asked something that I was wondering. What level is this at?
Oh, okay. This is, I want to say college. Probably an engineering level. I would say this is like intro mechanics, but it's for engineers, not life science majors. Do you cover this in high school? If you took AP Physics, you might. It's a little advanced for AP Physics. AP Physics C, for instance. I don't think it's out of the realm for A levels in the UK for physics. You dropped your
This
physics.
looks like year 1,
Yeah.
if I had to guess.
Yeah, year 1 of college, of uni, or A levels, I guess. But you would maybe cover this in an advanced high school class. Okay, wait, there's an M here. Okay, cool. All right. Now, this cool thing here is I'm going to get, I can pull an M out of both things. So I'm going to have M, and then we're going to have R omega squared cosine theta minus G sine theta. And then I'm going to pull the common denominator of the cosine theta outside of it. But then that's divided by, so dividing is the same as multiplying by 1 over. So this is multiplied by, still the same thing, which is sine theta tan theta plus cosine theta. So this is actually really cool how this is where trig comes in handy. You take 2 higher level classes in high school. I had maths and where are you from? One factum, by the way. What part of the world are you visiting us from? This is cool. Watch what happens here. Tangent of theta is the same thing as sine over cosine. Germany. Nice. That's cool. Okay, so then when you multiply this in, this will cancel with this, but it'll turn this into a cosine squared. So what you're going to end up getting is sine theta, cosine theta. But this is the same thing as cosine squared theta. And this is the same thing as sine squared theta. And then this is, again, why, you can't forget pre-calc or trig. Sine squared plus cosine squared is 1. So this goes away as 1. Okay. And now we're left with the right final answer, which was mr omega squared cosine theta minus G sine theta. And you're done. It's a cool question.
Well done.
I think that was only part A, though. Yeah, what's up?
Tell us about mains electricity.
Mains electricity? You mean like the electricity going into your house?
Yeah.
It's usually pretty high current, I guess. I think electricity going into a US house usually has to go into like a transformer box, which I want to say steps down 480 quad phase into 120. We can actually, we can ask ChatGPT. Let's see what ChatGPT says. Do you know about the Denevit-Hartenberg parameters? I don't. Let me ask ChatGPT what that is. Maybe it'll understand. Denevit-Hartenberg parameters. What are these? A way to represent the geometry of robotic manipulators, especially robot arms, by describing how each link is connected to the next. That's really cool. I'm not in Canada. One Factum's in Germany. I'm in the US. Oh, wow. See, this is cool. Do you see how everything gets eventually represented by a matrix? That's pretty cool. You know, this is probably useful for are those like automotive robots. You know what I'm talking about?
Watersprung durch Technik. Sorry.
Where's Burger King? That's a good one. Yeah, like these robots. These robots are pretty cool. So these robots have all these different axes that they have to go around, and I imagine that's kind of the links and stuff. Yeah, 6 degrees of freedom robots. Yeah, that's pretty cool. I was at a concert actually, where they were using robots to play the cello. It was pretty cool. What was this? Can I watch it on TikTok? Yeah, look at this. So they had these crazy robots like playing the cello. I thought it was pretty cool. And he's using like all these microcontrollers to do it. This is at the Sphere. Oh, that's loud. I wonder, yeah, what type of robots these are. It's mainly used for forward kinematics. Inverse kinematics is going from world space coordinates to joint rotations. Wow, dude, that sounds really advanced. I've never done that. That sounds scary. Oh man, the Romans fighting the Visigoths. Is that what you guys are talking about?
Nice meme. Shame if someone stole it.
Yeah. So I mean, when we say like easy parameters, no, you're not small brained. That stuff is kind of tough, man. It usually has to do with like transformation matrices, which again we know how to convert something in 2D circular motion, right? From polar coordinates to Cartesian. It's kind of the same thing, but you're just doing like 3D in terms of like angles, and I guess it's spherical coordinates, is it not? That when I see this like sine theta, cosine alpha, whatever, like this to me reminds me of spherical coordinates. So Jeff says yes, love it. Yeah, so this to me is how to represent things in 3 dimensions in terms of 2 angles and a radii, r or rho, which is Jeff's favorite thing. Jeff loves spherical things. Yes. If I understand correctly, the 3x3 matrix is a rotation. Okay, so we're talking about maybe this one. You do. He's an enjoyer of spherical stuff. R equals 1, Earth radius. Yeah, filler, interesting. Yeah, I'm actually curious about like, yeah, wait, what's the purpose of the bottom row? Curious. It's crucial for making the matrix part of a homogeneous coordinates, which allows us to combine rotations and translations in a single matrix. Why it's there? Rotations are handled by 3x3. I agree with that. Translations are vectors, so they can't be combined using just 3x3 math. I see. So it's kind of a filler that allows you to then do stuff with 4x4s. Very cool. Yeah, matrices are dope, dude. It's so cool how like computer logic, right? Packages and loops and like, you know, functions, all of this stuff gets encoded in math, right? The rightmost column is a translation vector. The bottom row ensures that it works properly with x, y. Okay, cool. And performs. Oh, okay, cool. Would you like to see what happens if you omit the bottom row? No, I'm okay. Physics is just math. You know, Jeff, we say that math was created for physics, right? Math serves at the pleasure of physics. I don't know, I find it so funny when we have a lot of really fun math friends here on the stream that also do more intense math stuff than I do. I tend to like top out at like DiffEq, LinAlg, and complex analysis. But we have some other people such as Zach and Penn Center who have degrees in math, like higher graduate level degrees that I don't. And they know a lot of really cool math stuff. So yeah, if you want to check them out on Twitch, please make sure you go follow those guys. They're really fun. And it's hilarious to see when they see physics questions come up, they get like all kind of scared. It's like, oh, whoa, this is like scary stuff. And I'm like, no, this is just like applied math. It's all it is. It's actually really easy. I think the stuff they do is very hard. When we're talking about like abelian groups and like transformations and like discrete math stuff, like that stuff like blows my brain, dude. Doesn't make any sense to me. Math exists outside any reality but describes all reality. True. Prime ideals. Let's see. So is there anyone on the Discord that can help with scary rotation matrices? Your best bet would probably be Penn Center. Here, and I'll shout him out for you. Did I give him the right? There you go. He loves linear algebra. It's one of his favorite things. He actually taught a linear algebra course here on like Twitch, and he is also doing a machine learning course. Yeah, I want to tell people about that. So if you go to our calendar, which is calendar.actual.education, I'll post the link here. We have a live stream schedule of all the different things that are happening, and Penn Center has a machine learning like reading group course thing he does live on Twitch and in his Discord, and that's Friday. It looks like Friday, kind of late morning. So this would be a great person to, you know, just get in contact with and, you know, hang out. It's a very fun crowd of people here. And you can just like learn stuff and ask questions. Zach would also be another good one. Either the 2i pi. He's a very good mathematician guy. Could probably help you out with rotation matrices. Let's see. If anyone doesn't have any other questions, I'll do part 2 of this one, because part 1 was fun. Part 2, find a similar expression for the tension in the part of the string of AB or AP. Oh, so that's T1. Oh, well, that's not very bad. That's not too hard, right? So if we wanted to get T1, so instead of solving for T1 here and then dividing out to cancel, you're going to solve for T2 and have that cancel out. So yeah, let's see if we can do that real quick. So here, let's do this. Let's solve for T1. Bad word usage. Don't get mad at Nightbot. No, not this one. Okay, let me pull this in. Okay, and I think I'm not going to use the tangent thing. I don't think I'm going to do tangent, because I think that ended up kind of screwing us over more than helping us. What program am I writing in? This is called Group World. It's kind of just like a whiteboard, is all it is. Yeah, Group World. I've been using them since probably 2015. I know there are probably better options out there, but I'm just so familiar to this, and it's rock solid. It never goes down. It has a lot of features I like. Like, it has built-in Desmos and stuff, which I think is cool. Well, when it wants to load. Yeah. So we can, like, do graphing calculator stuff on Desmos. Group World. Yes, correct. Here, I'll give you the link for it. I think I pay like $20 a month for it, but I use it for everything. So it's like, it's a business expense at this point. Like, yeah. And it has video too. You can bring people in and do video chat too. Okay. So if we solve this for T1, that means we need to now rearrange everything for T2. So this is what I was originally doing, right? T2 cosine theta is going to equal to mr omega squared minus T1 sine theta. And then from here, we're going to get that T2 sine theta is equal to, I want to say that's T1 cosine theta minus mg. Okay. Now, I think I want the mr squared stuff on the top, so let's just divide let's divide these like this. Okay. So T2 is going away. Okay. So now we have cosine theta over sine theta is equal to mr omega squared minus T1 sine theta. And then all over T1 cosine theta minus mg. Very cool. And now I want to rearrange for T1. So let's multiply this. Let's multiply this. So I'm going to get T1 cosine squared theta minus mg cosine theta is equal to sine theta, or let's say mr omega squared sine theta minus T1 sine squared theta. This is very cool. Now that we didn't convert to tangent, I automatically see that like this shit's just going to go away. Because watch what happens. I'm going to move this over here. I'm going to move this over here. I'm going to get that T1 cosine squared theta plus sine squared theta is equal to m. And then that's going to be r omega squared sine theta minus g cosine theta. And then this is going to be equal to 1, so this goes away. Yes. Oh, I got someone that's continuing to call me. What's going on here? Hey David. Teaching. Okay, alright, so T1 is equal to m r omega squared sine theta minus g cosine theta. And that, I believe, is pretty close to what we had last time, right? We had last time, what do we have? We had m r omega squared cosine theta minus g yeah, so see how the sine and the cosine theta just like switched? That's pretty cool. Nice. Okay. So there you go. That's an expression for T1. Let's see what they're asking for next. It is given that AB equals 5A, AP equals 4A. Show that 16A omega squared has to be greater than 5G. Oh. Okay. AP is 5A. Oh, they made this almost... They made it almost a 345. It's close, right? It's not, though. This is 5A. AP is 4A. Wait, no, wait. Yeah. AB is 5A. Oh, it is. It is a 345. Love that. I love when that happens, dude. Yeah. This is 5A. This is 4A. So yes, then we know this is 3A. This is a 345. Very cool. I think the reason why this comes in handy now, right, is that sine of theta is going to be opposite over hypotenuse. So that's going to be equal to 3/5. And cosine of theta is going to equal to 4/5. Okay. And they say, show that 16A omega squared must be greater than 5G. So I think what we have to show here is that there is some minimum speed you need in order for these things to remain tight. Because if it's not going fast enough, then there's not enough centripetal acceleration needed for these things to remain tight. It's usually what it is. You can think about, like, if this thing isn't moving very slowly, well, then this thing just, like, falls down. Right? The ring falls down. But if it is moving fast enough, then it will... what's called, like, a centripetal force, which is a fictitious force. There's, like, an apparent force pulling the ring out as this thing moves around in a circle. Okay. I think the one that's going to fail first would be this, right? I think when this is equal to 0, we're screwed. Okay. So, it's like those carnival rides? Yeah. Yeah, it kind of is. So wait, which one was that? T1? That was T2. So I think this has to be, I think this has to be greater than 0. Oh, where's my this? Okay, greater than 0. Right, because once the tension in the rope is 0, now it's no longer a tight rope. Now it's just like, it's just loose and floppy. No one likes that. Okay, so we can now replace cosine theta and sine theta with the ratios. And so this is going to be now, also the m goes away, right? I don't even care about the m. We just divide by m. So I'm going to get r omega squared, and then cosine theta is going to be 4/5 minus g sine theta, which is 3/5. And this has to be greater than 0. And I think they want something with g on the other end. Okay, cool. So I'm gonna add. Well, do I want to divide r omega squared as well? I feel like I could. Oh, no. Sorry, the r omega squared only hits the 4/5. That's why. Okay. Oops. Almost a mistake. Sorry. This is what's happening. Okay, cool. I think I got it now. Okay. So this tells me that 4/5, or let's multiply everything by 5. So I'm going to say 4r omega squared is greater than 3g. Okay. So now I need an expression for r. Okay. So if this is 3a, this is 4a. What is r? Oh no. Humbug. Okay. Well, I know the tangent of theta. I think this is solvable with trig. So if this is my new triangle I'm looking at, right? The sine of theta is equal to the opposite over the hypotenuse. So that's equal to r over 4a. So then 4a sine theta is equal to r, but sine of theta is 3/5. Right? So now I get 12/5 a is equal to r. Okay, cool. I think we're good there, right? Yeah. So r is equal to 12/5. So that's 48 over 5 a omega squared is greater than 3g. Or 48 a omega squared is greater than 15g. Which I can just divide everything by 3 again, right? So I get 16a omega squared is greater than 5g. Is that what I wanted? Holy shit, it is. Wow.
That's dope.
Wow, that's super cool. Yeah. What? Oh, that's super cool. Wow, look at that. Yeah, Lil Yachty got to come out for that one. That's actually really cool. Java. What's this meme you guys are saying, dude? What? 360p, 720p, 1080p, 4K Ultra HD. Oh, wow. Java's just absolute shit. Yeah, I get it. Wow. Okay, cool. So we got this one. Wow, this is a very cool question. Do you think you can go over the potential and kinetic energy of a spring when it becomes potential and when it becomes kinetic and the link to uniform circular motion? Ooh, okay. Yes. Let me think about that. It helps if there's a question, but I can also like try to create one. So, let's say, for instance, you have a spring. And you have a mass attached to it. You were watching the video and became confused on Kudu? Oh, for the new chapter, right? Oh, okay. Let me go see what the new video was on Kudu. Sorry, let me go see what they're talking about. Just so I can understand. Okay. What's our Miss PBS girl talking about? Oscillations. Okay. Okay, very cool. Yeah. This? Yeah, okay. So, yeah, with springs, right? What's up, a guy named Carlos? Yeah. You can have, let's say, for instance, this is like x is equal to 0. This is what's called like at equilibrium. Okay. Now, from mechanics, do you remember how we had like energy conservation and stuff, right? So we know the energy can be equal to like kinetic energy plus potential energy. In this case, it's potential energy of the spring, right? Kinetic energy is 1/2 mv squared. Potential energy of a spring is equal to 1/2 kx squared, where x describes how far away this thing is from its equilibrium position. So if, for instance, one second, I need like a solid square, right? If the spring moves out to here, for instance, okay, it is going to gain potential energy, because now x will be like some new x will be like big, right? And so 1/2 kx squared would get big, but that energy had to come from somewhere, right? So in order for something that's at rest, that's here to then get out to here, this had to have kinetic energy at first. Or here, let me describe it a different way. Okay. This is at rest. Let's say we have something here, okay? Let's say like new block, right? This thing is stretched, right? So the energy here, and let's say it's at rest. Let's say 1/2 mv squared is 0. And then we have 1/2 kx squared, which this is going to be big, okay? Let's say, like, for instance, this is just, like, equal to a. Okay? X equals a. Like, this is a distance a. Okay, when I let go of this spring, right? When I let go of the block, the spring is exerting a force, right? We know that's equal to kx, right? Or negative kx, which means it's always... The force of the spring is always opposite to the direction that it is away from equilibrium. So if it's being pulled positive x here, then that's going to force it to the left from a negative x, pulling it back. And the same virtue, if something's back here, negative x, then negative k negative x, this will get you a positive force, which pulls it back to the right. But anyways, this thing is going to start moving, right, back towards equilibrium. And as it does that, it is going to lose potential energy, right? Because the 1/2 kx squared term here will start to go down, because this will start getting closer and closer to 0. But by conservation of energy, you need the total energy to be the same. So as this goes down, you're then going to get an increase in your kinetic energy. And so that's why this thing, as it moves back, will start speeding up, okay? And so when it gets to here, this is when its potential energy is the least, so its kinetic energy is the most. Now it's going to keep moving, and it's going to move in a way that it starts compressing the spring. Okay? So as it compresses the spring, now your potential energy, your 1/2 kx squared, starts going up, because this thing is moving further away from its equilibrium position. And it's putting more energy into the potential energy of the spring being compressed. But that energy had to come from somewhere. And so that energy came from kinetic. So as this then goes up, this will start going down again. And that's why eventually this thing compresses to a point where it's at its maximum compression and the speed is 0. It's kind of the same thing. Do you remember in kinematics when we talked about like throwing a ball up in the air, and then we wanted to figure out where the maximum height was? And we knew that this max height, right, occurred when v in the y direction was equal to 0. right? When you had no more velocity pulling you up, that's when you had your maximum height. It's the same thing with the spring. Once you've run out of velocity, that's like rocketing you in this way, that's when you're going to be at your maximum compression. Yeah, a guy named Careless. Yeah, if you want to submit a screenshot of the formula, I can try to like derive it for you. Now, okay, let's see where this video comes into play with. No, not here. Where is it? Where's Kudu? Okay. Let's see what it has to do with like circular motion. And this is a pretty good. This is a pretty good. Like, look, all energy is in kinetic. Then all the kinetic energy goes to potential. That's why it stops. Then all the energy goes back into kinetic. That's why it's moving quickly. And then it's like, it's stopping. I wish they had like a little graph of all of it. They have a little graph of all of it. They really should. Okay, but now, oh, now they're doing this. Oh, this is cool. Yeah, okay. Good. How does a negative x go to higher potential? Because potential energy is 1/2 kx squared. Right? So even though x is negative here, Sib, even though x is negative, it's being squared, so that makes it a positive number again. So the potential energy is higher. Don't say that the potential is higher, it's the potential energy is higher. We're gonna go into potential later. That's a completely different thing. Let's see. We had rolls. What do we had so much stuff here. Where was... Okay, what they're talking about here, this is actually kind of cool. Yeah, so it turns out that if you were to measure the x coordinate of something going around in a circle, that also looks like harmonic motion going back and forth, like with a spring. So when things oscillate from back and forth from a spring, from being pulled and then going to the left and to the right, that follows basically like a cosine curve is what it does. And that's similar to circular motion, because you know that the x coordinate for something, like if you want to convert, this is actually cool. If you want to convert, for instance, let's say we have something going around in a circle here, right? You could get the two coordinates for things. So I could get what its y coordinate is and what its x coordinate are. Sorry, x coordinate. Sorry, this. Based on this like imaginary triangle, or this is theta, right? And then this is r. This would be r cosine theta. And you learn this. You learn like x is equal to r cosine theta. And then y is equal to r sine theta. Good to see you, Default. So as this thing like moves around in a circle, the x coordinate, right? And let's say like it's moving here, you know, at let's say theta is moving at a constant rate, then the x coordinate will oscillate like a cosine graph. It'll do like this. And that's simple harmonic motion, which is the same thing. So Jeff says, is the kx force based on an observation, or is there physical intuition behind it? What if it's going in an ellipse? Yeah. So what if it's Jeff says, what if it's doing this? Yeah, don't have it do that. Yeah, the cool thing for why it works for a spring is that if you have again something that's, I don't know, this spring, and it's going back and forth, right? This always feels a restoring force, which is equal to negative kx. So if I wanted to write out what the sum of the forces are on this object, I would say F is equal to negative kx, right? F is also equal to ma. So I say ma is equal to negative kx. And then the cool thing is that acceleration is the same thing as the derivative of velocity. So I can say m dv dt is equal to negative kx. And then velocity is the derivative of position. So now I can say m d squared x dt squared is equal to negative kx. Okay. And then you get that like d squared x dt squared is equal to negative k over m x. And this is a very famous differential equation. that we know the solution to it is that x is equal to cosine omega t, right? Where omega squared is equal to k over m. And I'll show you how this works, okay? So let's say, for instance, that we wanted to do this, okay? So if I put this here, right? This would be equals negative k over m. And then x is now cosine omega t. Let's look at what the derivatives of x would be if x is equal to cosine omega t. So dx dt would be equal to, so derivative of cosine is negative sine. And then you also got to do the derivative of what's inside, so you pull it an omega. So this is the chain rule. So this is negative omega sine omega t. And then the derivative of that is equal to, derivative of sine is cosine, but then you have to pull out another omega. So then this is omega squared cosine omega t. And look what happens when I put this over here now for d squared x. So I get omega squared cosine omega t. Oh, and sorry, there's a minus sign here. Almost forgot. Right? Because it was the derivative of negative sine. Derivative of sine is cosine, but then there's a minus sign. Okay. And watch what happens. If omega squared is k over m, okay, so now this is negative k over m cosine omega t equals negative k over m cosine omega t. So that works. And that's what tells me, this is called an equation of motion, by the way. You're going to learn this in higher level physics classes, mechanics. This is called an equation of motion. And how we got this equation of motion is we wrote out the forces, and then we wrote out the sum of forces in terms of a differential equation, and then we solved the differential equation. I think if you wanted to solve this, you have to use it's like e to the I omega t or something. But we just know that this is the solution for it, and then you just check it and it works. Yes, Jeff. Yeah, let me get to what you're saying. Why does a spring pull proportional to its extension? Yeah, that's called Hooke's law. I believe that's observational. I mean, let's ask ChatGPT. I'm curious. I don't know. I don't know the answer exactly. I'll say like, is Hooke's law derived from experimental observation, or is there some other science to it? I don't know. Let's just see what it says. Okay, so Hooke's law is empirically derived. It did not come, it came from experimental observation. Okay. So it was done in 1678. He noticed that the force required to stretch a spring is proportional to the displacement by F equals negative kx. Cool. Why it makes physical sense. While not derived from fundamental physics, it aligns with the atomic model of solids. Atoms in a solid act like masses connected by tiny springs. Okay, so that just like, whatever, that just reaffirms it. Okay, this is cool. Potential curve can be approximated by a parabola, which, yes, 1/2 kx squared, right, is the linear force displacement. That's cool. So, yeah, Hooke's law is based on observation, not deeper theory, but it is consistent with other things. This happens in physics a lot. Like, we go out, we do experiments, and we're like, cool, I think this mathematical thing describes this. And then we go test other things to make sure it's self-consistent and it makes sense. And if it does, great. Science. The force between atoms vanishes with 1 over r squared. Well, I mean, that's, yeah, I mean, that's the Coulomb attraction. There are other attractions, right? There's the strong force, there's the electroweak, there's gravitational. Yeah, so, yeah, the force between atoms, I don't know if it's strictly 1 over r squared. I mean, there's some other stuff. Again, I'll just ask ChatGPT. Yeah, exactly, not quite, right? Yeah. 1 over r squared does work for gravity and electrostatics, yes, but that's not all the forces in between atoms. Here we go. The Leonard-Jones potential. Oh god, yeah. Okay, there's short-range repulsion from overlapping electron clouds and Pauli exclusion. There's dispersion and van der Waals forces. Good. Coulomb's law is 1 over r squared. Correct. But yeah, there's other shit. That's like 1 over r to the 7th, 1 over r to the 13th. Strictly for charged particles and strictly for gravity, yes. But there are some other things that happen. Yeah. Yeah, it's pretty cool. I mean, there's a lot of stuff going on. A lot of stuff going on in the world. All right, I think this is the question that a guy named Carolus. Did you submit this one to me? Kind of a cool one. I don't know if I can answer this, but I'll try. Yeah, see. Oh, did you not post this? Someone posted this. If you want to post things. Oh, sorry. Okay. Yes. You're talking about. Oh man, who is that? That is Yeah. E to the I theta. What? Who's? Sorry. What rules that again, man? What is that? I'm losing my mind, dude. Gauss's. Thank you. Oh, no, Euler. It's Euler. It's Euler. Yes. Great. I forgot. Oh, Jeff. Yeah. So you can prove it using differentiation. That's pretty cool, I guess. You can do it using a power series. Yeah. Yeah, so, I mean, the way I interpret it is this. I think of, kind of like, I guess it's just like polar coordinates, right? That if you have something in the complex plane, right? And then this is your angle theta, that you're going to have an x component here, which is real. And that component is cosine theta. It's just whatever, but the radius here is 1, right? We assume everything. This is like r e to the I theta is equal to r cosine theta plus I sine theta. So I was just thinking about like, cool, this is the x component and this is the y component in the real imaginary plane. And then this is, right, this is real and this is imaginary. That's where I think of it. I see why this is maybe like confusing. Like, wait, why is it like e to the I theta is equal to this? Like, why is it e to the I times an angle? The original proof is based on a Taylor series. Oh, r sine theta. Oh, did I fuck that up? My bad. Sorry. Yes, r I sine theta. Yeah, sorry. Thank you. R I sine theta. You saved the day, Jeff. Get another save. Or first save it today. Okay. Yeah, so and this is cool. Then you can use it to derive the natural logarithm or something. That's really fun. And then once you have it, yes, you can come up with the definitions for sine and cosine. But I think I know what you're talking about. You're asking about like why is the e to the I theta like pick out an angle? I think it comes from using a power series to show that e to the ix, if you were to do the power series expansion for this, you could show that it breaks up into two components. You have like an oscillating part, or actually, sorry, they're both oscillating. But one does the even powers, right? 2, 4, 6, 8, and that's the cosine power series. And then 3, 5, 7, the odds, that's the sine. And then that shows you e to the ix is cosine x plus I sine x. And once you have that, you can then think of the x as being an angle in terms of polar coordinates in the imaginary plane. I like that. Cool. Yeah, multiplying by I rotates it by 90 degrees and something like that. If you square a complex number, for example, its angle grows by 2x. Yeah. Yeah. Right. And that's exponent rules, right? Because squaring something is just multiplying the exponent by 2. Right. And then we intuitively think of that x to be like the angle. The velocity, yeah, the velocity is always tangent, I guess, too. So that would be the derivative, right? Yeah, radius squares and theta doubles. Yeah. That's pretty cool. Okay. I hope that makes a little bit more sense, Careless. I like when people ask me questions like this because it's fun for me to. I have things that again I just know are true, like Euler's equation, but I don't really think all the time of like where it comes from. But it's cool to be able to like reflect and be like, oh hey, like why is that? I will say the person that asked me this question, V and V prime be isomorphic CG modules, prove that the characters they afford are equal. This is, bro, where like I get scared. Like what language is this? I know it's English, but like what language of math is this? Here, let's throw some really advanced ChatGPT at it. It's representation theory. Wow. Yeah, I have no clue what representation theory is, but I'm down to learn. Representation of finite groups. The theory of modules over the group algebra. Yeah. Oh wow. Yeah. Okay. Yeah. Here. It fucked up the LaTeX output. Here we go. So it says V and V prime are isomorphic CG. So it says suppose this, which to me looks like hieroglyphics. This is always like really interesting. That please burned one tree. not quite. Oh man. Yeah, they're talking about the trace, right? The trace is that's a linear algebra concept. Okay. This is the answer apparently. Ritu. I don't really understand how to explain it because this is a level of math that is above me. I like that it got asked because it's cool for me to. I'm always learning. I believe like life is a constant experience of learning, like lifelong learning. I had someone actually hit me up yesterday, old friend from high school, and she's like, hey, I'm turning 40 and I just quit my job and I want to go to nursing school, but I need physics and I haven't taken physics in forever. I have a master's in history and I'm really scared. Like, what should I do? And I was like, oh, first of all, I love that for her. I love that she's going, first of all, she's like saying, yeah, fuck my job. I'm done. I'm going to go be a nurse. And she's realizing that, yeah, her history degree isn't going to get her anywhere in nursing, but she's willing to like get back at it and start taking intro physics courses, which are her like, you know, prereqs in order to go to nursing school. I think that's really cool. So, and that's what I say with lifelong learning. I'm just like, yeah, now she wants to learn a new skill. And most people at 40 would give up. They'd be like if they were in a job they hated, they'd be like, well, this is it. I guess I'm just going to die now. So, you know, even though I am 35, I have a PhD in physics, I don't know everything. And so I like it when people submit things I've never seen before because it's cool. Groups, rings, and fields are abstract algebra. Yes. Cool. I love when math, for instance, starts getting so ridiculously difficult that they start giving it simple names. You know? They'll just be like, yeah, circles. Or like number theory. I'm like, numbers. Yeah, I know what numbers are, right? Yeah, cool. And it's always like, it's so innocuous. You think it's like not going to be really difficult. And then you do it and you're like, oh God. No. It's really, really, really tricky. Wait, someone submitted a I call this like Facebook soccer mom math. Let's see what this question is. And then this will be the last one, then I'm gonna close the stream out because I do want to go to the gym. I want to get some exercise in today. I'm getting fat. Alright, here we go. Many won't get this right. 2 plus 2 times 2 minus 2. Okay. Well, order of operations. We do multiplication first. Let's see if I get this right. Am I smooth brain today? So this is 4. So then you have 2 plus 4 minus 2. And now since it's all just adding and subtracting, you go from left to right. So this is 2 plus 4, which is 6. 6 minus 2, which equals to 4. I think the answer should be B. Am I correct? I'm pretty sure I'm correct, right? Just to make sure I'm not crazy. I'm going to tell it, now that you did abstract, I'm going to confuse the AI. It's like, bro, I just did representation theory, abstract algebra. Like, how do I solve this one now? Yes. Answer is 4. Okay, great. Will this question be on the final?
That's dope.
That's too fucking funny, dude. No, it won't be on the final. That is a funny joke in like classes. Students get really concerned about everything on the board being like, is this on the final? Is this on the final? Is this on the final? Jeff says, 2 things are isomorphic if there is a 1-to-1 onto function between them that preserves some operation. Oh, okay. Is that the whole thing about like if 2 numbers multiply by each other to get another number inside the group? Is that like the preserve some operation? Or, oh, okay. FA plus B is equal to FA plus FB. That's closure. See, the one thing I never got with my ex.
You done messed up, Aaron!
Okay, cool. All right, if we don't got any more questions, I think I'm gonna close the stream out. I want to go to the gym. All right, cool. Thanks. Thank you, everyone, for coming to Office Hours Actual Education. Appreciate it. Yeah, there's a lot of lingo, dude. There's a lot of lingo in math. A lot of lingo. Anyways, that's our last stream of the week. So I hope you guys had fun. I got to go to a wedding this weekend in Denver, so I'll be out. But stay tuned in the Discord. We are going to start summer camp on July 7th. So if you want to sign up, win a Nintendo Switch 2, go check us out on our Discord. It's right there. There's the link. Yeah, I'm glad you found us, Careless. That's cool. What we're going to do now is we're going to go raid somebody. Go raid someone. Who do we got? Raid a channel. Who am I following? Someone doing science and technology. That's cool. Chat, I'm cooked. It's 4 a.m. The sun is rising. I've been there before, dude. Yeah. Oh, I like these people. Yeah. Ask a Scientist. These guys are really cool. So what they do is they play video games with like a professor or like a scientist or something, and then you can ask questions as they're playing the game. So this looks like a molecular biology genetics guy, and he's talking about bugs. This is cool. Lithuania, wow. Very cool, Careless. I'm glad you found us. All the way. We've had people from like Bosnia before. Eastern Europe. Cool place. Okay, go say hi to our friends at Ask a Scientist Gaming. Otherwise, enjoy the weekend. Have a great, wonderful rest of your week. We will see you guys on Monday. Peace.